In a study of 433,666 cell phone users, it was found that 141 developed cancer of the brain or nervous system. Assuming that cell phones have no effect, there is a 0.00034 probability of a person developing cancer of the brain or nervous system. We therefore expect about 148 cases of such cancer in a group of 433,666 people. Estimate the probability of 141 or fewer cases of such cancer in a group of 433,666 people. What do these results suggest about media reports that cell phones cause cancer of the brain or nervous system? So in part A, we want to estimate the probability of 141 or fewer cases of such cancer in a group of 433,666 people. So the first thing we want to do is identify the values of N, P, and Q. The sample size N is 433,666. The probability is equal to 0.00034, and Q is the complement of P, so 1 minus 0.00034 is equal to 0.99966. So now we want to be able to calculate the values of N times P and N times Q. So we want to be able to check. So N times P is 433,666 times 0.00034, which gives us 147.446, which is greater than 5. 433,666 times 0.99966 is equal to 433,518.554, and that is also greater than 5. Therefore, we can say that the normal distribution can be used to approximate this discrete probability. Now we want to be able to find the mean and the standard deviation. So the mean is equal to N times P, and the standard deviation is equal to the square root of N times P times Q. We found the mean from the first part because mu is equal to 433,666 times 0.00034, which gives us 147.446 for the mean. For the standard deviation, we're going to take the square root of N times P times Q, which gives us a square root of 147.396308. Rounding it to 6 decimal places, the standard deviation is 12.140688. Now what we want to be able to do is draw a normal distribution centered about the mean, which is 147.446, and then draw a vertical strip area centered over the value of 141. So x here is equal to 141. Since it is 141 or fewer, it is the same as at most 141. So it does include 141 and below. So we're going to shade to the left of the continuity correction. So let's go ahead and draw our bell curve. So we know that the mean again is 147.446. And we know that the value that we want to draw is at 141, which is to the left of this. So therefore we have 141. And so since it is 141 or fewer, it's the same thing as at most 141. Now at most means that we include that value and below, and it's to the left of the continuity correction. So the continuity correction represents a discrete whole number x by the interval of x minus 0.5 to x plus 0.5. Since we want to include 141, we want to take 141 and it's below. We're going to take 141 plus 0.5, which gives us 141.5. So that means we're going to draw here where we want the location of 141.5. So now we need to determine that we want to find the area. And the area, since it's 141 or fewer, it's going to include 141 and below, so we're going to shade to the left of 141.5. So now that we know that, we need to convert that 141.5 to a z-score. So we know that the mean is 0, and then we need to convert that to a z-score to find out what is the z-score for 141.5. And then rounding that to 2 decimal places, using the mean to be 147.446 and a standard deviation of 12.140688. We're going to plug that into our z-score formula. 141.5 minus 147.446 divided by 12.140688 gives us negative 0.489758. Rounding that to 2 decimal places gives us negative 0.49. So therefore this z-score is going to be negative 0.49. And since it's to the left of 0, that tells us that it's true. So now what we want to do is be able to use StatCrunch to find the area that's to the left of negative 0.49. So opening up StatCrunch, select Stat, Calculators, and then Normal. We know that the mean is 0, the standard deviation is 1. We already have it less than or equal to, so we have it shaded to the left. Now we just need to put in our z-score of negative 0.49. And that gives us the following area, or probability. So now what we're going to do is we're going to round that to 4 decimal places. So the area to the left of z is equal to negative 0.49, round to 4 decimal places is 0.3121. Therefore, the probability of 141 or fewer cases of such cancer in a group of 433,666 people is 0.3121. In part B, it says, what do these results suggest about the media reports that cell phones cause cancer of the brain or nervous system? Now, the media reports suggest that people who use cell phones are more likely to develop cancer. Think about whether the results of this study can be used to support or refute that claim. Well, the probability of 0.3121 is greater than 0.05. So the media reports appear to be incorrect because one would expect that more than 141 cell phone users would develop cancer. And in fact, the study may offer some evidence to suggest that cell phone use decreases the probability of developing cancer.